Everything working?
Yep.
So the thing was not working yesterday?
Yeah, it's a broken adapter, I guess.
Right.
Or like maybe this adapter needs to be like powered, so like maybe only some of them are.
Okay.
Yeah. All right. Hello. Hi. Good morning. Hello. Hi. Hello. Hey back there. Hi. Good morning. All right, let's go ahead and get started. So today we'll be talking about functions, and we'll essentially break it down into three parts. We're going to first talk about expressions and names. So a little bit of review from last lecture. And then we'll move on to environment diagrams, which is the way we'll be analyzing programs in this course. It'll give us like a foundation or a structure that we can use to kind of really understand what's going on in Python. In the very end, we'll introduce you to, again, some of those topics like the environment in Python, like how it figures out what names evaluate to what, for example. So again, all this stuff will be made clear within this lecture. So without further ado, let's go ahead and talk about announcements. So first up is, make sure you set up your computer, so essentially complete Lab 0 by tonight. If you still need help, there are no more labs after right now, but you can still come to office hours. So that's what office hours are here for. Definitely feel free to take advantage of those. And make sure that your account on okpy.org shows that you've submitted Lab 0. So it won't count for a grade unless it says like with that little green dot that says submitted at this time and you're all good. Discussion sections also begin today. Feel free to shop around, but try to decide by next week. Again, our general guideline is we found that it helps if you have the same discussion TA as your lab TA. So if you can, try your hardest to find a matching section. There's also going to be a quiz on today's material, but it'll be on Thursday's discussion. So you have like a little time to like digest it, get some practice in discussion today, and then apply it and figure out like how well you're doing on Thursday. So it's going to be a one exam level question. You'll have 10 minutes to complete this question, and it's going to be multiple choice. So this is a completely new format that we haven't tried before in CS61A. So the idea with this is to not stress you out. You'll get full credit for reasonable effort, no matter how well or how poorly you did in terms of correctness. So as long as you complete something and you submit it in discussion, you'll get full credit for that. Homework 0, the pre-semester survey, is due Friday at midnight. And there's also a class potluck on Friday from 5 to 6:30 at Memorial Glade. Do you want to talk a little bit more about it?
Okay, hi, I'm Ashley. I'm Angela.
Hi, I'm Kelly.
So we are from the course climate team, which means that it's our job to make CS61A as fun as possible for you guys. So we're planning a course potluck this Friday from 5 to 6:30 on Memorial Glade.
Yeah, be sure to come out. You can meet a lot of people. You can meet everyone who's in 61A as well. Maybe find a project partner, as well as course staff will be there too, so you can meet us and just talk to us. It'll be a good time to just like talk and de-stress. There's more information on Piazza, so be sure to sign up for that. There's an RSVP, and make sure to bring food, games, and friends.
It's okay if you can't bring friends, because friends will be there. But let us know if you have any ideas for any other events that you'd like to see, and we'll see you there. Thank you, guys.
All right, thank you so much for Climate team. And of course, lab checkoffs will start next week. So essentially, the system with lab checkoffs is that you attend maybe one lab a week at least, and in that lab, you can check off on, I think, either a homework or a lab. All right, so let's go jump into the content, expressions and names. So expressions, a little bit of review from before. There are two types of expressions. Primitive expressions, which evaluate directly to values. And some of those include numbers, names, like add, and strings, like hello. So kind of the distinction I want to bring up, because I think I saw a great Piazza post, someone asked a question about this, was what does it mean to evaluate, essentially? So if I look at this, for example, the name add. My example that I used with add was to say, when you type add into the interpreter, you're typing characters, right? Letters, ADD. How does Python know that that means the function that adds stuff? It knows because it goes through a process called evaluation, which says read in ADD and figure out what does ADD mean to me. And like sometimes, like I showed in last session's interpreters, we saw that Python actually doesn't know what ADD means by default. You have to teach it a little bit by doing that from operator import add. So there's this idea of context that we'll be exploring today. Like, what does add mean in this context? What does add mean in some other context? In addition, we also learned about call expressions, which have the three rules: evaluate the operator, evaluate the operands, and then you can apply, which is the call to function. So an example of that would be 1 times 2. That's an example of a call expression, which is equivalent to mul1, 2. And an example of that, again, is max of 2, 3. What I do is the first step is I evaluate the operator. Then I evaluate the operands from left to right. So I first figure out that's my first operand, because it's before the comma. And this is my second operand, and then I apply, which is to call the function and actually perform the computation. Yeah, quick question. What's up?
Why do we actually call add from operator and not call it from math like we would with like sign or pi?
I think the idea with operator is that it provides like more basic utilities. Like for example, add is equivalent to the plus sign, right? So it's something that you kind of see, like the plus sign works by default in Python, but to import add is to like do that additional step to say, I really explicitly want to do, instead of doing the plus sign, I really want to use add, the name ADD. And we'll learn more about names in this lecture. Is that a good answer, or did I kind of miss the fact?
I was just wondering why do you call, like, why would that not, or is that just in operator because it's such a simple function and it's not being called to math because math is more of like a complex math ideas involved?
Mm-hmm. Yeah, like math, for example, contains like constants like pi, which isn't really an operator maybe, and like sign, for example. So these are like more complex operations that you really don't say is like a single operator, like the plus sign or the minus sign or the division symbol, right? Does that kind of build up your intuition? Okay, cool. What was your name again? Ethan? Ethan, thank you for the question, Ethan. All right. So today we'll be talking about names in particular. So how do you know what ADD means? So giving names to values makes programming easier. And so an assignment statement is one way to bind a name to a value. An example of that would be x equals 1. That's an assignment statement, x equals 1. Each name can only be bound to one value. Environments keep track of names and their values. And here's the rule for how to execute assignment statements. This is something that's kind of tricky. Like the rules are pretty simple, but it's kind of tricky to actually apply them. The first step is to evaluate all expressions to the right of the equal sign from left to right. So in the case of the x equals 1 example, the things to the right of the equal sign is just the character 1. And so when I evaluate that character 1, I go from the character 1 to Python's understanding of the number 1. So now Python knows I'm talking about the number 1 on the right side. Then I bind all names to the left of the equal sign to those resulting values in the current environment frame. So what this means is I'm going to look at the left of the equal sign, which has the x character, right? And what Python is going to say is, I remember on the right side, I had that number 1. Now I'm going to say, let's associate x in my environment with that number 1. And let me do a quick demo of what that looks like in the interpreter. Oops. All right, is this big enough? All good? All right, cool. So I'm going to start at Python 3. Then I'm going to go x equals 1, like we saw in the example. And so Python doesn't print anything, or the interpreter doesn't print anything when you just make an assignment statement, because there's no return value. Then I'm going to do y equals x plus x. So how do we understand this statement? Well, I remembered that I bound x to be 1. So now when I evaluate, if I follow that rule again, I evaluate the right side, right? So I figure out what x plus x is. So the way to evaluate x plus x is it's a call expression, right? So I can just say, what's x? X is 1, because I'm looking up x in my current environment. And I already know I bound x to be 1. And I'm going to add that 1 to 1. So I'm going inside of that call expression, I'm going that evaluating the first x, I figure out that's 1. Evaluate the second x, I figure out that's 1, and then I plus them together to get 2. So now that I've evaluated the right side, I have 2 on the right side. I'm going to bind that to y. So now y means 2, hopefully. So if I quickly check that, I can say y is 2. And what is x? X is 1. So far, so good. I can also do more complex assignment statements, assigning 2 things on the left. So that means I would need to give it 2 things on the right. So if we follow that same rule again, the rule was evaluate everything on the right from left to right. So I'm going to start with this one right here, x plus y. I'm going to figure out what x plus y is and remember it. So x is my current environment is 1, y is 2, so that'll give me 1 plus 2, 3. And then I evaluate the second thing on the right, which is x, and x is still 1. So I'm remembering that I have 3 and 1. So notice I did everything on the right side first. So remember I have 3 and 1. I'm going to bind that to be x, the new x and the new y. So x will be the new 3, and y will be 1. So if I quickly check that, what's x? X is 3. What's y? Y is 1. Questions about this, or do you want me to try anything out really quickly? Yeah?
Does it evaluate x, then plus, then y, or x, y, then plus?
Wait, can you repeat that question again? Sorry.
Does it evaluate, because you said it evaluates from left to right, so I'd expect it to go evaluate x, then plus, then y, or does it evaluate x, y, then plus? Does that make sense? Like, does it evaluate, because the plus is an operator.
Mm-hmm.
So does it evaluate x plus then y, or x, y, then plus?
Yeah, great question. There's actually a little bit of Python magic behind that I don't want you to know or worry about right now. You can essentially just say Python knows about plus. So don't worry about it too much for now. We'll touch about it maybe like halfway into the course, but only a little bit. Is that okay? Okay, yeah. Yeah, any other questions? This is great. What's up? Where do we bind y to 1 in this example? Right here? Oh, notice on the left side, there are 2 assignments. We're assigning to x and to y. X comma y on the left side, right? So let me type that again. X comma y. And I have 2 things on the right side. So it's like I'm matching up the first thing on the right with the first thing on the left. Does that kind of make sense?
Oh, okay, now I get it.
Yeah. Can I get your name again? Sorry.
Zach.
Zach, thank you. And what was your name? Josh. Okay, thank you, Zach and Josh, for those questions. Anything else real quick? Yeah, what's up?
So, I just wonder if you change the order into each side, should you change the order?
If I change the order,
Yeah, because is that possible then to all x and y together or?
oh, great question. So, was your question, if I change the order of maybe y comma x, you mean?
Yeah, y is x.
So like, y comma x equals x and x plus y? Oh, yeah, great. So I think your question is kind of hinting on if I, if I change y first, is it like sequential versus is it all together, right? Because if I change y first, then when I evaluate x plus y, it will be different, right? Is that kind of what you're getting at? Yeah. So again, remember the evaluation rule says, figure out everything on the right, and then assign them all to the left. So you compute everything, remember everything on the right, and then only then do you assign it to the left. So with this, we would say, at this point, the binding for x is 3, right? So I'll say, I'll remember the first one is 3. I'll remember the second one is 3 plus 1, 4. So I should get y is 3, x is 4. So y is 3, x is 4. Yeah, so when you have these like dependent things, it still follows the rule. Evaluate everything on the right, and then only then do you start assigning. Great question. That's a very subtle point. What was your name again? Sorry? Sorry? Hunjin. Thank you so much. All right. Let's move on. So back to the slides. Oops. All right, so we figured out how assignments work. Now let's talk about an example. So I'm going to give you a couple lines of code. First one starts with f equals min. Then f equals max. Then g comma h equals min comma max. Max equals g now. And then what's this? Your job is to evaluate this. Give you a moment. Give you a minute. Think about it on your own, and then I'll let you break up into people around you. You can talk about anything. So spend a minute thinking about that on your own. If you already know the answer because you looked at the slides, be quiet. Ten more seconds. Do a little more thinking. Okay, so before you get talking, can I get a show of hands? If you think it's 1, put up 1 finger. If you think it's 2, put up 2, 3, 4, or 5. So hands up. What do you think it is? 1, 2, 3, 4, 5. A lot of you have seen the lecture slides. Cool, so we have a pretty diverse group of answers. Now go ahead and convince the people around you why you think your answer is correct. Okay, let's wrap up our talking. Hi. Hello. Hello. Hi. Hello. Hi. I know you guys are really excited. I'm really glad. Hi. If you can see me, wave back at me. Hi. Hello. All right. So the moral of this story is that This is a hard problem. So our goal is to figure out some way of trying to kind of procedurally or have some kind of solution to try to figure out like, how can I solve these problems if I were to see them again in the future. So I'll leave you hanging here for a moment. We won't see the answer just yet. Instead, we'll go on a detour, which is to talk about environment diagrams. What are environment diagrams? This is an environment diagram, but unfortunately, it's not what we want. Sorry, NASA. In computer science, environment diagrams visualize the interpreter's process, what the interpreter does, and how it does it. So here's an example. First, we have code on the left, which shows me, hey, my first line is x equals 1. My second line is y equals x. And it'll show me those statements and expressions, and the arrows, if you notice up there, indicate the evaluation order. So I see I have an assignment statement, for example, like y equals x, and the little light greenish, tealish arrow indicates a line that just finished execution, and this red arrow means that I'm just about to run that line. And so if I already bound x to be 1, if you look at the frames on the right, it'll show me that each name, for example, x, is bound to that value 1. And names cannot be repeated in a frame. So that's just like an important point that you want to hammer back. So the name here would be x, and its value is 1. And this as a unit is called a binding. Let me take a look at a demo. Okay, demo time. All right, here we go. We have x equals 1, y equals x equals 2, and x comma y equals x plus y comma x. So if I go ahead and start running this code, it looks like I'm just about to execute line 1. And so I've executed line 1, which says x equals 1, and in the environment diagram, it shows me that I bound the name x to the value 1. Likewise, it shows me here that I just executed the first line, and I'm about to execute the second line. So if I keep on going, y equals x, I evaluate what x is 1, and so I should bind y to be 1. And there you go, y is 1. Now if I say x equals 2, I do the right side, which is the number 2, and then I do the left side, which says I'm going to bind that to x. So now x should change to 2. But notice that y didn't change. That's a really important point here. Y does not change. Because again, we remember that we evaluate everything on the right side. So when we did that original line, y equals x, I didn't have y like follow whatever x is. I said, let's figure out x right now. What is the value of x right now? And that value is 1. And then I bound that to be x. Then if I execute this statement, I'll do that same rule. Let's figure out x plus y, 3, x, 2. So I should get 3 and 2. 3 and 2 in our diagram. There you go. So that's how an environment diagram works. We run through the code line by line, and then we record how the environment changes in the global frame, for example. Okay, next slide. Cool. All right, so now let's go ahead and go back to our example of the hard problem, and let's look at a demo. So here, I'm going to go draw the first couple lines to set up our environment. This will help us finish that long line, because that line had like max, f, g, h. Let's figure out what those actually are bound to. So if I say f equals min, I've now bound f to be the function that chooses the min of all of its arguments. Now if I say f equals max, f will be bound to the max function instead of min. And notice in that step that I didn't have like a second f. You can only have one f in each frame. So now f equals max, so it overwrote that previous binding. Now if I execute g comma h equals min comma max, I figure out min goes to g, max goes to h, and so I get g is min, and f is also the same max function. And now if I rebind max to be g, I'll figure out what is g? Well, g is the min function. So I remember g is the min function, and then I bind that to the name, the characters in the name max. So what I should get is max here pointing to the function min, which is really confusing. So this is why we have this diagram. It'll help us when we're later trying to look up stuff. Okay, here we go. So we finished the demo. And remember, here's the environment diagram. So if I use these bindings, I want to look up what max is because it's the operator. I go here, and I look up what's max. Max is this, which is the min function. So actually, max is the min function. And so if I keep on going through, the next step is to figure out what's my first argument. This is something I didn't really touch on last session, so I want to give you a little hint. This is really complicated. But the hint you want to use is find the matching parenthesis. So for example, I have max with an open parentheses right here, right? And then I say f, this is all going to be part of a big argument, but I don't know how big it is. So I'm going to look through. It's 1 opening parentheses, 2 opening, 3 opening. So I'm still like making lots of function calls. I haven't finished this first argument. Then I have 1 closing, 2 closing, and then 3 closing. So then I'll notice that this is the matching closing parentheses with this one. So this is all part of the big first argument. So if I look at that big argument, since it's a call expression, I have to do more work. And so I do the same procedure of looking up what is f. F is the max function. What is 2? It's number 2. And this g, this is a call to g, which is another call expression. So look up g is the function min. The first argument is calling h of 1 and 5, and h is the max function. So h is max. And 1 and 5 are just numbers 1 and 5. So then you notice at this point, I have underlines, or essentially I've evaluated all the parts of this. I've evaluated the operator, and I've evaluated the operands. So at this point, I can then call apply on this one. And so I apply max on 1 and 5, which gives me the bigger of those two numbers, or the number 5. Now I evaluate that. Now I can evaluate 3, which is just number 3. Now if I take the min of 5 and 3, I get 3 back up. And now I figured out all the operands here. So I can say, let's take the max of 2 and 3, which is 3. And now I can go back up here and look at the next operand, which is number 4. So if I take the min between 3 and 4, it'll give me 3, which is our final answer. Magic. All right, lots of questions. Let's go around. Yeah?
When you try to evaluate max equals min or max equals g, it crashes, or it doesn't work.
Really?
I believe it's an issue with the namespace.
Okay, so what was your name again?
Greg.
Yeah, so Greg's question was, would it cause problems if I try to assign max to be g, like namespace issues? Okay, so you can bind built-in names like max to anything you want. Max doesn't even have to be pointing to a function. It could be a number. Yes, so very important point that you can change even like these things that are assumed to be there and have them refer to something else. And that something else can be anything. It could be a number, it could be true or false, like we saw last lecture, a string, anything. But great question, Greg. Yeah?
Does that mean that if we delete or reassign an h, we lose access to the built-in function max?
Oh, yeah, great question. What's your name? Braun? Yeah, so Braun asked, if I reassign f or h, or f and h, would I lose access to max? And in this case, if we look at our current environment diagram, yes, we would no longer have access to the max function because we've completely lost any kind of reference to that function. And that's kind of because like f and h are the only ways to reach max right now. Because if I refer to, if I just say max to Python, it'll think of the min function, right? There's no other way to reach max other than through f and h. Yeah?
Why doesn't f get rebalance your point to min after max is changed?
Oh, great question. What was your name?
Ryan.
Yeah, so Ryan asked, why doesn't f get rebound to min when, if we go back to the Python tutor, right? So here, is there something about this? You want to back up a little bit? And which line is it on?
Well, on the last line when you said max and g,
Okay.
that changes the value of calls to max, but it doesn't change the output of calls to f, or even though f is pointing to max. So why is that?
Oh, great question. Yes. So remember the rule for evaluating an assignment statement. It says figure out what's on the right, evaluate the right side, and the right side of the equal sign just says evaluate what g is in this environment. So g is the function min, right? Following so far? Okay? Okay, cool. I'm going to assign that to the name max, max. Max has no intrinsic meaning to a computer. It means something to us because we can understand that max is like shorthand for max in English, or maximum in English, right? But to the computer, it doesn't mean anything. It's just some arbitrary name. And I can assign that arbitrary name to anything I want. I don't think I really answered your question. Do you want to clarify that, or was that satisfactory?
Like, because you could have the max function
Yeah.
that f is pointing to. That max function has to be pointing to some like some instructions in the computer code, right?
Mm-hmm.
But when you're redefining that max function, it's pointing to a set of instructions. So why is f still pointing to that bullet set of instructions and not?
Yeah, great question. So how can I still access max even though I have something called max here? I think it's kind of if you notice at the top, it says frames and objects. It's something we won't really touch on until later in the course. But just as a quick preview, this function max is just like any other function, right? It's some function which exists somewhere in the computer. The computer has some way of knowing that this is what max does, because there's some function that exists for it. And so that function can exist independent of the name. Like it doesn't matter that we call it max or anything.
I guess he's asking, why doesn't it go back and change what f is doing when you're rewriting the new code? Why doesn't it change what f is originally assigned to when you just change the meaning of what f was?
I'm not really sure I get you. Do you want to talk about it afterwards? Yeah. Is that okay? We'll have to cut off questions a little bit short. Definitely come up and talk to me afterwards about this. This is a very important topic. So I really appreciate the questions. I'm sorry about that. Okay. So that's max. Let's go ahead and look at functions. So functions, in this class we'll be doing a lot of defining functions. It's probably like the biggest topic. This is like everything in this class is about defining functions. So functions have inputs and outputs. So a function signature, if we look at this code right here, this is like a structure of a function. A function signature indicates name and number of arguments. So the name comes after, like I say def space, then I give it the name of the function I want, whatever I want to call it. Then I put an open parentheses, and then I put in the parameters. And what the parameters are essentially like a list of what you want to call the arguments later. So we'll get more into that later. The function body defines the computation performed when the function is applied. And here's how you execute def statements. So def statements here are to define functions. First, we create a function with signature name and parameters, like I mentioned earlier. Then we set the body of that function to be everything indented after the first line. And then lastly, we bind the name to that function in the current frame. So I think this kind of hints at what we saw earlier with Greg's question. Is that right? Oh, sorry. What was your name again? Yeah, Ryan's question. So Ryan's question, which was about how I can still access max. There's something about this detail, this third part in particular, that is, I think, kind of shows you a little bit more. So we created a function which can exist on its own without having a name. And it only happens to have the signature that happens to have the same name. Then we set the body of that function to be everything indented after the first line. So it gives the function meaning. It tells it what instructions to run. And then lastly, it's only here that we do some kind of binding so that we say, here's how you look up max. It's because we give it the name max in this environment. And as an example, we'll be exploring the square function, which takes in an x. So then inside the function, whenever I say square some number, I can then refer to x to say that's that number that I'm talking about. And I can say mol xx, which is like one way of defining square. And at the very end, I can say y equals square of -2. So the first two lines, the def and the return, are part of the def statement, which tell us this is what the function is defined as being is defined. And the last line, y equals square of -2, is how you use that function. It's how you call it, right? Because we call the square function we just defined with -2 as the argument, and then assign that to y. Okay, so let's go ahead and jump more into calling user-defined functions. So the procedure for calling or applying user-defined functions, this is the version 1 because we'll see like a more advanced or a different version as we learn more about Python. First, we create a new environment frame. And then we bind the function's parameters to its arguments in that frame. And lastly, we execute the body of the function in the new environment. So as an example, let's go ahead and look at that square example again. So I went ahead and taught Python how to what mul means on the first line. And then I do the def statement. And this def statement just tells Python, this is what square is going to mean after that block. And so if I go ahead and look at my environment, I've defined mul means the function that multiplies things. And I've defined square, this is my function. I've defined square to be the function that squares stuff. And so mul is the built-in function, and that's my function. And so here, when I then try to execute this line, when I called square of -2, the assignment statement will call square of -2, and that goes ahead and goes in the body of square. Notice that I jumped to square, and then it started running some lines. So the first thing it did was it went to the def square line, it finished that line, and what it does is it makes a new environment frame there. So it creates something called a local frame, and this information right here you can get from the function signature. So for example, we call that frame square, and we get that name from the right side right there. And this name is technically called an intrinsic name. So again, a function signature has all the information needed to create a local frame. And so here's when I start doing the binding. Again, I haven't yet run the return line yet. So what I'll do is I'll say x, which I got from the function signature, is going to be bound to the value that I just passed in, -2. So I'm going to put -2 over there, and that's how I finish opening this frame. So all of this was one step before we got to the body of the function. So the formal parameter is bound to the argument. And then when we actually execute that line, when we actually run the return line, I'll then multiply x with itself. So -2 times -2, or 4. And then what I do is I put that into something called the return value, which is not a binding. And that return value and so that return value is what will be assigned to y at the end. Okay, break. We can go ahead and talk about those questions we had earlier as well. Thank you so much. So maybe 5-minute break. All right, hello. Hi there. Hi. Welcome back. You made it. Hi. I think it's gonna be a thing now. Hi, thanks. Hi. If you can see me, wave your hands. Say hi. 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 All right, I kind of wanted to revisit this example. Can I get a show of hands? Who's sick of this problem? Or who still wants to see it again? Maybe not as much. Do you think this example would help? Yes? Okay, I guess we'll spend like a couple minutes on this and then kind of go back to what we were just talking about. So Ritalia brought up a good question, which was kind of the distinction between max the name and max the function. Still kind of hazy, so I think maybe this will help a little bit. So if we look at this, if I set my first line to be max equals 7, the evaluation rule for that says, let's evaluate what this character 7 means, which is the number 7, right? And then assign that to the name M. So I have the number 7 assigned to the name MAX. Then I'm going to execute this line, which says, let's first evaluate what min means. And min, by default, Python is built in, knows that min means the function that minimizes among all of its arguments. And so I'm going to bind that to the name f. So I'm going to have f is the min function. And then the next line, I'll set f equals max. But in this case, when I'm trying to evaluate what max means, max, instead of looking in the built-in, I look at in my current environment, because I've defined max to mean 7, I evaluate max to be the number 7. Then I assign that to the f. So now f is 7. And now if I say g comma h equals min comma max, I first figure out min's the function that minimizes among its arguments. Max is max, in this case, because I'm looking up in my environment, says it's going to be the number 7. So I have the min function and the number 7. And finally, I can reassign max to be g, which in this case, g is the function that minimizes. And that's how the environment changes. So I have a quick question. Hands? Yeah, what's up?
Hi. My name's
Hi.
Howard.
Howard, hi.
I'm confused about what a primitive expression is.
Okay.
Does a primitive expression have to have intrinsic value? Or is it just like, as you say, let's say like ADD, like doesn't necessarily mean anything?
Right, yeah. So the expression itself might be like, before Python evaluates it, before Python understands what it is, the primitive expression refers to, like, for example, the character's ADD.
So,
and then when you evaluate it, you get the
intrinsic
value.
value like min that Python automatically knows is like take the smallest number. Is that considered a primitive expression?
Yeah, it is primitive because it's not you're not calling something. So I think maybe the other criteria is like if you're not calling something.
Okay.
Yeah, there you go.
Thank you.
Any other questions? Yeah, what's up?
So primitives like strings and values
Yes.
are not objects. Like,
Oh.
because in the environment, like,
Mhm.
objects, I'm just wondering, are they-
Yeah, what's your name? Will. So Will had a question. Strings and what was the other thing?
like, just all primitives.
Okay, yeah. So what qualifies as a primitive? Sorry, was that the question?
Yeah, like,
Yeah.
are primitives objects, or are they not objects? What is the class of objects?
Yeah, good question. So the way we represent like this definition objects is a little bit arbitrarily defined in this tool called Python Tutor. So in Python, basically everything in Python is technically an object, but there are certain properties that we'll learn later on in this course about why we can say that the number 7 just means number 7, or the string hello is just a string hello. So the distinction of it being, like, is your question like why don't we draw an arrow to 7 or? Yeah. So depending on like if you're familiar with like other languages, you might also know that there are this idea of objects would mean that you'd have to have 7 over here and you draw an arrow to it. There is some truth to that, yes, but we won't really touch upon it. And I think it's more important that we focus on this, like having a standard diagram that everyone understands. So for simplicity, because we haven't really learned that much about objects yet, let's just accept this truth for now, but there is more to it, yes. Any other questions? Yeah, back there. Anyone wants to just raise? Go.
I was wondering if the word environment as frame for
Environments and frames. Good question. So what was your name? Warney?
Martin?
Wharton. Yeah, so Wharton's question was, what's the difference between environment and frame? Can they be used interchangeably? An environment is like a sequence of frames. In this case, we only have one frame, the global frame. So the environment is just going to be the global frame. So in that case, we can kind of use them interchangeably. But the technical definition for environment is that it's a sequence of frames, and we'll learn more about that later. Yeah?
When max is reassigned to min, why don't F and H get reassigned to min also rather than 7?
Okay, so when, how many steps do you want to go back? Here?
Yeah, well, earlier on in the script, F and H get assigned to max, which is assigned to 7. And then at the end of the script, max gets reassigned to G, which is min.
Okay, so this line is
F and H get reassigned to min.
Okay, so this is the tricky line you mean? Like, why does this cause, like, why does this only change max?
Exactly. Why does it only change max and not F and H?
Yeah, great question. So this is kind of something we saw earlier as well, where we saw that when I was trying to do that x and y example, I had like 2 numbers. I had x equals like 1, for example, y equals 2. And then when I changed x, it didn't change y. So this assignment statement just says, first figure out what g is, and then assign whatever g is to the name max. To the name max, only the name max. So everything else is like unchanged. We're only changing max. That's just how Python works. This is the rule. Like some other languages might do it differently, but in Python, we only change max in that assignment statement.
But F and H are max by definition, right? So should that change what F and H are?
F and H are not max. F and H are 7. I think that's like, it's pretty subtle.
Okay.
Because we first, here for example, this is how F became the value of max. I want you to listen to that, the value of max. Not max itself. F is not assigned to max itself. It's assigned to the value of max.
Okay,
at that time, exactly. The value of max at that time, which was 7. And it doesn't like follow max anymore. Does that clarify?
Yeah.
Okay, cool. Yeah, one more question from you. Okay, hi.
Under frames, is it only the variable? Do you only list all the variables from the function? Or like
Here? Yep. Oh, yeah, so for simplicity, we don't show like the built-ins. Like there are like a lot more built-ins, like min and max. How does Python know how to look them up? We don't show them in this case because of simplicity, just to keep your diagram like just the important parts essentially. Yeah, great question. What's your name? Vipitha? Vipitha. Deepika. And what was your name again? Sorry, I missed it. Martin? Martin? All right, we'll check in on you again later. All right, back to slides. If you have other questions, definitely feel free to talk to us afterwards. Okay, environment. So this is kind of, back there, what was your name again? Oh, both your names, yeah.
I'm Sam.
Sam, hi.
Hi.
And you asked about environments, right? What was your name? Wharton? Wharton, yeah. So Wharton asked about environments. Here we are talking about environments. So let's give you an overview of what we've covered so far. So it's like a lot of moving pieces. I want to give you like kind of like a summary of what we've done so far. The first step is that we create a new function and the name bound to that function in the current, and we name down to that function in the current frame. So here we see I've defined a function square, and what that does to my environment is that I say square now refers to the function square. Does everyone follow? Questions? We define square through the function square. So that means we've bound inside of our environment. We've said square means the function square. And so after that, I can then try to call the function using this example. I can say y equals square of 1 minus 3, for example. And the evaluation order says first figure out what the operator is, then evaluate the operands, and then apply. So this is that call expression step. So after we define it, we can then use that function. So here it says, let's evaluate square, which refers now to the function square. And I can evaluate the operand, which is 1 minus 3, to give me the argument, -2. And finally, we can create a new frame to actually compute what square does. And what I do is I bind x to that argument -2. And this creates a new environment where x is -2, and then I compute mul of -2, -2, which gives me 4. And so that makes that local frame where I have the binding x to be -2 and also that return value. Quick question? Yeah, Sudambi, hi.
So going back to where you're saying bound into that function in the current frame.
Oh, yeah.
So I'm assuming that that's the global frame, right? Or is there any case where a function where a name can be bound to a function without in the global frame?
Yeah, Sudambi, great question. So that's a topic for Monday's lecture on higher order functions. So where can you have other things than the global frame? We've only seen the global frame so far, so that's all you have to worry about for now. Okay, cool. Any other questions before I move on? Sorry. Oh yeah, so Stan's gonna walk around and like answer your questions. So you can just say like hi to him, or wave at him, or do something to get his attention. Okay, so what we're gonna do now is we're gonna look up names in environments. So every expression is evaluated in the context of environment. So I mentioned this earlier. How do you give meaning to ADD? You have to look it up in the environment, and that environment tells us that it's bound to the function add. An environment is a sequence of frames, and so far we've only seen 2 possible environments. We've seen the global frame, as well as a local frame, and then the global frame. So this is where that idea of frame versus environments kind of like shows up again. If we saw earlier that we could have just the global frame, for example, the big F max GH thing only had a global frame for that we saw. But the square function, for example, when I evaluate square, I create a new local frame. And then that local frame, if a name cannot be found in the local frame, it will then go up in the global frame. So we'll talk a little bit more about that soon. So the rules for looking things up is I first look it up in that local frame. So for example, if I think back to the square example, if I looked up x, I can find it inside square's local frame because x was defined as the parameter. If that name isn't in the local frame, I can look it up in the global frame. And if a name isn't in either frame, then I'll just give what's called a name error, which is the computer telling you that I can't find it. Okay, so as an example, here is that square function again. This is a slightly more complicated call, square of 3, nested call expression. So I've gone ahead and completed the from operator line, the defining square. So those are the 2 things on the right-hand side. And so when I try to decompose this call expression, what I'm going to see is I see that the name square evaluates to the function square that I defined earlier. And if I break down this call expression, I'll see again, it's the function square. And 3 is number 3. And I got all of that information by looking it up in my environment diagram. So now that I can evaluate this, I'm going to create a new frame that says, a new local frame that says, whose intrinsic name is square, and with a parent called, a parent of the global frame. And what we went ahead and did was we bound the formal parameter x to the argument 3. And then when we compute the return line, it tells us return mul of 3, 3, which is 9, and then puts that in the return value box. And that's how we get the 9. Then when I go back, now that I computed this inside call expression, I can then compute the entire call expression now that I know the argument is 9. So just like before, we're going to create a new local frame, with 9 as the argument, and compute 9 times 9, which is 81. So notice that I created a new local frame. I didn't reuse the previous one, but it has like the same information, like the same intrinsic name, the same parent, but just different bindings inside of that frame. Then finally it gives us the computation for 81. And as a recap, an environment is a sequence of frames. So let's see visually how that works out. We either have the global frame alone or local than the global frame. So if we just look at global frame alone, I could, like at the very beginning of this entire sequence of operations, I just looked up the name square. And looking up the name square happens only inside the global frame. I only look in the global frame for the name square. The alternative is I can look in the local when I'm calling square, for example. When I made that nested call, I looked in the local frame, that one, and then I looked in the global frame next. And same with the entire nested call expression. I can look in F2, the local frame for F2, and then look in the global frame in that order. So if I'm trying to look up a name like X, I'll look first in F2, for example, and if I can't find X there, I'll look in the global. So that's what that rule means. Questions about this procedure? I went through a lot. Yeah?
So what is def defined as? It's not a function like max. Is it has a different syntax? Like, what do you define def as?
Oh, yeah, what's your name?
Isaac.
Isaac. So Isaac asked, how do you look up def? Like, what does def mean to Python? Is that the right thing? Okay, yeah. So what does def mean to Python? It's a bit of syntax. So it's like a special keyword Python understands is part of what you use for a def statement. So it's not looked up at all. Yeah, so there's like no lookup procedure for def. It doesn't like say go in the global frame and find a binding for def. Like you can't rebind def because def is like a super special keyword. You can't change it. Great question. Yeah, back there.
What frame is the original statement?
Great question. What's your name? Ethan. Yeah, so Ethan. Oh, Ethan asked. Thank you for that question. Ethan asked, what frame is the return statement evaluated in? So in this case, are you concerned about the mul call? Is that what you mean, or?
Yeah.
Yeah, so mul is a built-in function, and as a rule, we don't really understand how built-in functions work. Like they usually do some magic, or like they're inside of Python, so we don't create new frames for that. But you're right that it would be a call expression, and you would make a new frame. But for simplicity, we don't include frames for built-in functions. But the return statement would otherwise be evaluated inside the regular frame that you already made. There's like no extra frame construction when you just do a return. But of course, if I called like some other function I defined, then I would create like a new frame, compute all that, and then return back up. One more question over there. What's up?
In the expression that evaluated to 81, is the outside function the global frame or the local?
I'm sorry, outside function. Oh, is this one?
Yeah.
The outside function. And what was your name?
Yeah. Was it like the local or global?
Is this one local or global?
No, the one above.
Or the entire statement, you mean? The entire expression?
Yeah.
Okay, yeah. So the question was, is that entire expression, square of 3, is that local or global?
Yeah.
So it's interesting. So when you're trying to do stuff like evaluating the operator and evaluating the operands, you're still inside the global frame doing all of that work. I first figure out what is square, and at that time, if I go back, very beginning, there's like 2 stages of this. There's like the very beginning, I'm figuring out what square is. I only have the global frame. So I look up things in the global frame because that's where I'm being called from. And then later on, after I finish all that computation, It's only at the point where I actually call square that I make a new frame. And then inside the body of square, I look inside the body of square, and I start computing stuff using the rule for looking up from F2. Does that clarify, or did I kind of miss the mark? Okay. Yeah. Anyone else? Yeah, what's up?
I guess it's just like, so you're saying like square and then like the one after return is like double frame, so like which one is like?
I'm sorry, can you repeat that question?
Like I'm not sure like which one is double frame. It's like you're defining like square and then one like double, so I don't know like.
Yeah, good question. What was your name? Yeah, Erica asked, how do you know which one's the local frame I'm looking at right now, you mean? Or is that what you mean? Or, because there's like two local frames here, right?
Yeah, so I'm not sure which one.
Okay, great question. Yeah, so Erica asked, how do you know which one I'm using right now, you mean? Or?
No, I mean like, is that like the square and then multiple, they're both like local frame, and then
Yeah.
I use them to like do a function. But like I'm not sure like which one was the length of the function.
Can you repeat that last part, sorry? Okay. So there's a local frame for F1, right? Does that make sense so far? So when I compute this one, this nested call expression, because we know this one computes before the outside, right? This one uses the F1 local frame. And its rule says, look in F1, then look in global. When I compute the outside call, I create a new local frame for the entire call expression, for the outside call. And that one's rule says, look in F2, then look in global. Does that help, or do you want to talk about it afterwards too? Yeah. Okay? Okay. Okay. So, if we're moving on, print and none. None means that nothing is returned. So the special value none represents nothing in Python. And nothing as in like there is some kind of value for that, nothing. Functions that do not explicitly return a value will return none. And none is not displayed when evaluated by the interpreter. So here's an example of a program that does not include that return statement. So here you notice def does not return square. Notice that there's no return, the special return keyword before x times x. So that means if I try to call this line does not return square of 4, what I'll end up getting is nothing displayed by the interpreter, because even though it's computing x times x, is doing that work of computing x times x, this function returns none, but that none is not displayed by the interpreter. So you'll see no line after the running that code. But what it does return is it does return that none. So if I'm trying to evaluate this assignment statement, what I'll do is I'll figure out what does this right side give me. It gives me none. I'm going to assign that to the name 16. So what I'll get is the name 16 is now bound to none. So if I try to do 16 plus 4, for example, 16 evaluates to none. So if I try to do none plus 4, then it'll give me an error. So Python's saying I can't add none and a number. Okay, so as an example of kind of like contrasting the two types of function we've seen so far, I have pure functions which just return values that we're used to. For example, the square function returns a number. And we also have non-pure functions that have side effects. And we'll see an example of that soon. So here, I've given you a pure function like pow, which computes the power of the first argument raised to the second power. So for example, I can say 2 raised to the 27th power. That gives me a big number like that. So it takes in 2 arguments and can return a single value like that number. But a non-pure function, for example, like print, what it does is it takes in as many arguments as you want. It returns none. But along the way, it does something like this. It displays the output 2 space 27. So it says, take all of my arguments and then put a space between them. It returns none, but it's not displayed by the interpreter. So we saw earlier that the does not return square function, when I try to call it just on its own, it returned none, but Python didn't show that value. But what the print function does is it actually does end up printing this. It does display this. It displays this, but it returns none. And so this is a side effect part. A side effect isn't a value, it's anything that happens as a consequence of calling a function. So in this case, it just prints 2 and 27, but you can't do anything with that 2 and 27. So if we look at a nested expression, here's just some practice for what you can try to do with this. Given this nested expression, print of 1 and print of 2, what does it print out in Python? So there will be a couple lines of output. Try to think on your own for a little bit, applying the rules from before, where remember that print returns none, but shows the values that it was given with the space separated between them. So think on your own for a moment. All right, let's come back together. Hi. Someday. Hi. All right, let's get back on it. So the output for this is a little complicated. There's more than one line of output. Hi. Hi there. Hang in there with me. We're almost done. This is the last topic, but it's really important. This is definitely going to be on the exam. Please listen. That's how I get everyone. All right. So this has a couple lines of output. And it does this. Did it match with your expectations? So the nested call expression print of print 1 and print 2 first gives us 1 on its own line, 2 on its own line, and then none, space none. So why does that occur? Let's look into that. So if we first remember the evaluation rules, because of the nested call expression, I do all this stuff with like figuring out the operator and the operands. But since we already kind of know those rules, let's go ahead and skip towards the interesting part. So I'm going to evaluate print 1. And what I get is I'm going to pass the argument 1 into the print function. Print returns none and shows the value 1. So that's where that first line for 1 comes from. It shows that number 1 on its own line, but returns none. So that's going to be an important fact later on. And notice that it's colored in like this gold color. Then we're then going to call print 2 because that's the second argument, right? This is how we evaluate the entire nested call expression. And so for that, I create like a little print function, and I pass in the 2, and the same thing happens. I return none in California, and then I print out 2. that's where that second line for 2 comes from. The first line for 1 came from the first print call. The second line for 2 came from the second print call. But here's the kicker. They both return none. So they both return none. And so what that means is that I'm essentially then going to call the last print function with the 2 arguments, none and none, that were passed in from the first print, and this one passed in from the second print. And so when I do that, it then prints out, it shows that last line with none space none, and returns none to the interpreter. So the one special thing here is that this last none is not displayed, but this line that's printed is. Does anyone want me to replay a part of this and go over it again? This is a really, really important topic. Yeah.
So, is this showing us that Python values will guarantee values back to right? Because it shoots the print 1 before it chooses print 2.
Yeah, great question. What's your name?
Mark.
Yeah, Mark asked, is this showing that it's going left to right? And yes, with regards to the operands. So it evaluates the operands from left to right. Yes. So just the operands. What's up?
Why is it only one opposite if there was two in the step time? Will there always be one opposite?
Yeah, great question. What's your name? Sorry, Justin? Was it Justin? Yeah. So Justin asked, why is there only one output? So I can have multiple inputs, yes. But in this case, print just returns one output. It's just what print does. There are like ways of returning more than one thing, but we'll learn more about that maybe halfway through the course again. Does that address your question, or do you want me to clarify? Cool. Anyone else, maybe from the back? I haven't heard much from the back. Back, you got questions? All right, hi, what's up?
So if I just put print 1 over print 2 into Python, I get 1, 2, and then I have none in parentheses. Why is the parentheses none in parentheses? They don't have that function necessary to print.
Oh, what did you say? It was you, if I call...
Print 1 over print 2, I just input only that into Python. Then my output is in print 1, 2, and then in a third line, that's none, none in parentheses.
I think we'll have to take a look at that closer. Do you want to come later on, come up and bring your computer to me so I can see that? Yeah, and then we can maybe share that with the class later. Yeah.
1 and 2 are still the side effects of the second print and the third print, but then the first print is none and none are the actual output.
Yeah, so this output none is then passed into this one, right? Because that's where we wanted to figure out what print 1 gave us, right? And it gave us none. But it also, along the way, printed out 1. Does that make sense? Exactly. So the side effect of this is to put a line with 1 on it right here. The side effect of this is to put a line with 2 on it right here. And then the actual part of calling this print just gets the none and the none, and that's where this print happens for the last box. Does that make sense? Cool. What's up? Good question, yeah. So the way the print function works is that you give it multiple arguments and you separate them, those arguments with commas. But what the print function does is it prints it out with spaces between them, which is how it works. Any other questions? What's up? Yeah. If I input a pure function that returns none? Yeah, so even if I didn't have this output, like let's say we had a function that returned none, but didn't print out anything. Is that what you mean? Is this a question about how the print function works, or? Can't quite hear you. Do you want to talk about it afterwards? Yeah. Okay, any other questions? I won't be able to move on to the very last slide, so we'll probably just end here if you don't have any more questions. All right, last one. What's up? Shh, please stop shuffling. Class is not over yet. You have 1 more minute. Hang in there. You got this. What was your question? Sorry? Let's talk about it afterwards. All right. Otherwise, class is dismissed. Thank you so much. No.
Can I get your office hour?
It should be online on the course website.